Hello students, I welcome you all in this session of quick solutions for All India AIATS Test Series for JEE Advanced 2020, test number 6A, paper 2, code C&D, subject physics, test dated on 16th of February 2020. Straight away, let's start with question number 1. Here in question number 1, a uniform disk of radius r is spun to angular velocity omega and then carefully placed on a horizontal surface. The coefficient of friction is 0.25. If the time taken by the disk to stop is given by n omega r divided by g, then find the value of n. It's a very particular question of rotational motion, and I guess you must have gone through it once at least. Well, let me give you the explanation here. This being the disk here, it was spun with angular velocity omega and then placed on horizontal surface. So I'll be taking the small segmental area of width dr, so this much of the region shall have the area of 2 pi r dr, and if sigma is the mass density, so this one is the small mass under consideration. Now if it's been rotated along this direction, so the friction force will be acting opposite to the relative motion, or I would say the friction force in this direction altogether. It will be mu times normal. Mu is this much and normal is how much? Dm into g. So I would say sigma 2 pi r dr into g. This is the friction force, and the friction force shall have the torque about this point. What would be the torque here? The torque will be square of this part, r to be multiplied with this force. This is the torque that will be acting about this point. So the total torque will be integral of this tau, or I would say it is mu sigma 2 pi g integral of r square dr. It is r cube divided by 3. This is the value of the torque here. Fine. So what about the angular retardation now? If this is the torque, so moment of inertia would be m r square divided by 2. So it is mu sigma 2 pi g, this one is r cube divided by 3. This is the torque, and moment of inertia is m r square. It is r square into 2. And what about the value of m here? It is sigma into pi r square. So have this calculation, and we'll be getting this value to be, this pi will cancel out here, and the sigma will cancel out. This is we are remain with 1 r here, so it will be 4 mu g divided by 3r. This is the value of angular retardation. So we need to find the time taken by the disk to stop completely. It will be alpha into t would be omega, or I would say t is omega divided by alpha. This is 4 mu g into 3r. We'll have this calculation now, and how much is the value of mu here? It is 1 by 4. So I guess it is 3 omega r divided by g. Have this comparison with the one given here in the question. So we are finding the value of n to be equal to how much? It is 3. So for question number 1, 3 is the answer. Now let's proceed to question number 2. Here in question number 2, a circular loop of radius 10 cm and carrying current 2 ampere is placed in a uniform magnetic field so that its axis coincides with the field direction. The radius of the wire is 1 mm and breaking strength is 32 into 10 to the power 7 Newton per meter square. Find the minimum strength of magnetic field in nearest integer in kilotesla so that the loop may rupture. Because of the magnetic field, the loop will experience a force in outward direction, I would say, and because of that part itself, the tension will develop, and if the tension being sufficient enough to break the loop, then how much would be the magnetic field in the region? That's the calculation we need to make here. Okay, let's have this part here first. Let the radius be r and the current is I and the magnetic field is B and the current is flowing along this direction for the time being. This angle I'm considering this part to be theta and this part also be theta, and the theta is small here. So in that case I would say tension T will be along this direction and T will be along this direction. So definitely 2t sine theta Sine theta will almost be taken as how much? Theta itself. So it is 2t theta must be the force acting in this direction, magnetic force. Fine. So how much is the magnetic force this time? It is I dl cross B. I is I here. dl is R into 2 theta and the magnetic field being P. So this 2 theta will cancel out and we are left with tension to be equal to IRB. Once we found this tension, now what is the stress that will be developing across this circular wire? So it will be tension divided by area. It is IRB, area being pi into r square, radius of this wire actually. It's been given to be 1 mm. So it is 1 into 10 to the power minus 6. This must be equal to the breaking strength that was given to be 32 into 10 to the power 7. Okay, so find the value of B from this calculation. We will be left with 32 into 10 to the power 7 here into 10 to the power minus 6 into pi and divide by I was 2 ampere here into R, that was 10 centimeter, that means it will be 10 here. Have this calculation, it comes somewhat very close to 5024 Tesla. So we need to find this answer in kilo Tesla. So I would be saying the magnetic field is 5 kilo Tesla. So for question number 2, 5 is the answer. Now let's proceed to question number 3. In question number 3, a rod of mass 1 kg and length 1 meter is placed on a smooth rails and projected towards with velocity 10 meter per second in uniform magnetic field B is equal to 2 Tesla as shown in figure. Resistance of the connecting wires and the rails is negligible. The distance moved by the rod in meters until it comes to rest is. What we know here in this situation, once this velocity is provided, there would be some EMF on this rod and the current will be flowing in such a way that this rod will experience a drag force in backward direction. We need to evaluate, or we need to formulate the equation and find what would be the distance that it must be traveling before it comes to rest. Straightforward, I would say. Let's say at any particular time instant, the velocity being V and magnetic field was inward, so this end will be the positive terminal of the battery that would have been said to be developing because of motional EMF. So I would say E to be equal to VBL. So what would be the value of the current that will be flowing in this resistance this time? It will be VBL divided by R, and the force that this rod will experience in backward direction, it will be F retardation, I would say, I dl cross B. So V B square L square divided by R. Fine. So how is the value of dV dt? It is retardation. So I'll be taking the sign to be negative. It is B square L square V divided by M into R, or V dV ds is minus of B square L square V divided by MR. This we will cancel out, or dV is, integrate this part with proper limit. Initially the velocity was V0 and finally it becomes 0. So I would say it is V0 would be equal to B square L square. S is the distance it will travel into MR. Have this calculation for S. It is V0 was 10, mass being 1 kg, resistance was 2, and B value was 2, so square would be 4, L it was 1. So it is, we are finding the value of S to be 5 meter. Got it? So our answer is 5. That's the answer for question number 3. Now let's proceed to question number 4. In question number 4, an open tall tank of height 5 meter and cross-sectional area 0.7 meter square is filled with water completely. A small hole of area 2 centimeters square is made near the bottom. Find the time taken in hours to completely empty the tank to the nearest integer. Situation is a very standard one. I would say let this height being h, area is a, small hole is made here with the small area a. So at any particular instant, if the height is small h and the velocity here is capital V. So I would say A capital V must be equal to A into small v. This small v is the velocity with which the liquid will be coming out from this small area. So what we know here, A V divided by capital A must be equal to capital V. What we know, this capital V is actually minus dH dt. Fine. So I would say minus of dH dt would be equal to this much, and this small v is how much? It is root 2gh. Integrate this part with proper limit. We shall have dh divided by root h must be equal to A capital A. Here it is root 2g dt with negative sign. So it is 2 root h would be A capital A root 2g into t. So with negative sign 0 it was capital H, at t it becomes 0. So we'll be getting 2 root h here, and it is. Now from this equation please have the calculation for this t. So it will be 2a small a on this side, h divided by 2g. This is the value of t. If we make this calculation, we'll be getting this value of t to be very close to 3500 seconds. So if we transform this time in second in hours, we'll be getting this t to be almost very close to 1 hour. Actually 1 hour is equal to 3600 seconds, so it is 3500 seconds. That means almost close to 1 hour. So the nearest integer is 1 hour. Our answer is, for question number 4, it is 1. Now let's proceed to question number 5. In question number 5, in the circuit shown in the figure, find the total amount of heat generated in R1 in joules after the switch S is open. So once the switch was in closed state and the system has reached its steady state condition, so in that case the current that will be flowing in inductor will be 3 divided by 1, that means it is 3 ampere. Fine. And once the switch is open now, so this inductor will try to drive the current along this direction, and the total amount of energy that was actually there in the inductor was lost, and that will be appearing as the thermal dissipation across these two resistances. So the total energy in the inductor was how much? It is 1 by 2 L I square. It is 9. So this time it is 18 joule. Okay, and this 18 joule will now be dissipating across this R1 and R2. So definitely the power dissipation across the resistance, what we know, it is P is equal to I square R. It is proportional to the resistance. So I would say this is 2 ohm, this is 1 ohm. So the total energy that will be dissipating in R1 will be 1/3 of this 18 joule. So how much it is? Energy dissipating in R1, it is 18 divided by 3, that means 6 joule. That's the answer for question number 5. Got it? So now let's proceed to question number 6. In question number 6, a vessel of volume 20 liter contains a mixture of hydrogen and helium gas at temperature 20 degrees Celsius and pressure of 2 atmospheric. If mass of the mixture is 5 gram, then find the ratio of mass of helium to that of hydrogen gas in the mixture to the nearest integer. Simply it will follow the equation of ideal gases. I would say the total pressure PV is equal to nRT. How much it is? P, that's been given to be 2 atmospheric here. V was 20 liter. Okay. N, how much it is? Let the mass of hydrogen is M1 and the mass of helium to be M2. So in that case I would say M1 plus M2 was given to be 5 gram. Here the total number of moles would be N1 plus N2. N1 being how much? It is M1 divided by molar mass of hydrogen to be, it is 2 plus M2 divided by 4. This is N1 plus N2 into R into T. Just have these values here. We will be getting PV 2 M1 plus M2 RT here 4. So 2 M1 plus M2 4 PV divided by RT. 4 P, it is 2 into 10 to the power 5 here. Volume to be taken as 20 into 10 to the power minus 3. R to be taken as 8.314 into temperature being how much? It is 273 plus 20, it is 293. Have this calculation. We'll be getting this calculation very close to 6.6 gram. So by taking this 2m1 plus m2 to be equal to 6.6 and m1 plus m2 to be equal to 5 gram, we'll be getting the value of m1 to be equal to 1.6 gram and m2 to be equal to somewhat close to 3.4 gram. So we need to find the ratio of mass of helium to that of hydrogen gas. So the ratio would be m2 divided by m1. It is 3.4 divided by 1.6. That will be getting this value to be close to how much? 2. So for question number 6, 2 is the answer. Now let's proceed to question number 7. In question number 7, a screw gauge with pitch length of 0.5 mm and circular scale with 50 division is used to measure the thickness of a thin sheet. Before inserting the sheet, when two jaws of screw gauge are brought in contact, the 45th division coincides with the main scale line and the zero of main scale is barely visible. If the main scale reading is 0.5 mm and 35th division coincides with the main scale line, then thickness of sheet is x divided by 10 mm. Find the value of x. We need to understand here how the screw gauge and the circular scale was actually adjusted. This was the zero marking here. In fact, initially we need to find the least count of the system. Pitch length being how much? 0.5 mm. That means it is 5 divided by 10. And each of this part is actually being divided into 50 further division. So it is 50. So I'll be saying it is 1 by 100 mm is the least count of the system here. Before inserting the sheet, it's been said that 45th division coincides with the main scale. Here 45th one coincides with the main scale. So this portion, if I would be taking here, this will be how much? It will be the 5 division. So actually the error here is in negative value. Or how much is the error? It is 5 divided by 100 mm. This is the zero error of the system with the negative value. We need to remember this part here. Now let's proceed with the further instruction. Now if the main scale reading is 0.5 mm and 35th division coincides with the main scale, then we shall have the reading as 0.5 mm plus 35 divided by 100 mm. This would be the reading, and we need to adjust the zero error of the system. And how much it was? It was 5 divided by 100. So this will be the actual thickness of the sheet. So how much is the answer here? It will be 50 divided by 100 plus 40 divided by 100, and we are getting this value to be equal to 9 divided by 10 mm. If we compare this answer with the one given here in the question, then we are getting the value of x to be equal to 9. So for question number 7, 9 is the answer. Now let's proceed to question number 8. Here in question number 8, a He plus ion is excited to the quantum number n on transition to ground state. That ion emits 2 photons in succession with wavelengths of 108.5 nanometer and the other being 30.4 nanometer. Find the value of n. Use Hc to be equal to 1240 electron volt nanometer. This to be n is equal to 1, 2, 3 and further here it was n. Then the energy that actually came out by the successive emission of the wavelengths, it was 1240 divided by 108.5 plus 1240 divided by 30.4 in electron volts. It must be equal to 13.6. Z being how much? 2 here, so it was 4, and it is 1 minus 1 by n square. Have this calculation for n. We will be getting this value to be close to 52.2 electron volt. So it is 13.6 into 4 1 minus 1 by n square. So once we make this calculation, we will be getting this value of n square to be very close to 24.87 something, or n would be how much? It would be 5. So for question number 8, our answer is 5.